Welcome to AI Australia, brought to you by Eliiza. On this show, your hosts James Wilson and Nigel Dalton have in-depth conversations with technology leaders, academics, and AI professionals about all things artificial intelligence. We'll explore a broad range of topics, including AI strategy, technology, and ethics, providing valuable insights for Australian businesses at all stages of AI adoption. And now, your hosts, James and Nigel.
G'day everybody, welcome to the Australian AI podcast. This is James, I'm here with Nigel. How are you doing today, Nigel?
Very good, very good. I'm deep in artificial intelligence land at the moment with my latest Audible book that I'm listening to, AI Superpowers by Kai-Fu Lee, which I'm all over. It's a fascinating story, and but here we are with a real human being and a man of similar expertise and experience in the world. So I'm very excited to be here, James.
I'm very excited too. So we have a pretty awesome guest today, and it's great to be able to profile yet another local Aussie who's kind of leading the charge globally around AI. So our guest today is Tim Miller, and Tim's an associate professor in the School of Computing and Information Systems at the University of Melbourne. And Tim's really carving out a pretty fascinating niche in an area called Explainable AI, or XAI as it's also known. And his work's really at the intersection of AI, interaction design, and cognitive science and psychology.
And I'm happy to be here because it's got a social science element to it. So I may understand a percentage of the things Tim says today, which is fantastic. And what a place, University of Melbourne, have seen the biometric mirror, went up to the exhibit that was going on there. I think they're raising some incredible ethical questions and user experience questions, and it's brilliant. I love Australia being at this point of the argument, not just worrying about data and mathematics.
Absolutely. All right. Well, welcome to the show, Tim. It's great to have you here.
Thanks very much for the invite.
You're most welcome. So, Tim, you've established yourself as a global voice on this topic of explainable AI.
That's very kind of you. Yes.
Can you share with our audience how your career's kind of unfolded and what's brought you to the point where you are today?
So I mean, effectively, I did a PhD in software engineering, and then decided I wanted a bit of a change, and I got a position as a research engineer in an AI lab in the University of Liverpool in the UK, where I picked up the AI bug. So, as I said recently on a radio interview, I'm a bit of an AI hipster. I was in AI before it was cool, and I've been around a while. And when I came back here, I've been working on various projects, but the explainable AI thing really came out of, I've been working on trusted AI for about 5 years. And explainable AI came out of a whole lot of conversations I had with people that were all bringing up the same concept. Was we deployed this application to so-and-so, and people rejected it because they couldn't understand why these decisions were coming about, and therefore they didn't trust it. And I had enough people say that I started talking to more people and figured out, well, this is an interesting problem to work on, that I can build on my background and do something valuable.
So explainable AI, it's not a new thing necessarily. It's getting a bit of a resurgence at the moment. Is that right? Yeah,
it's been around. I mean, since the expert systems in the 80s, there were some people. William Clancy is one from IHMC, was working on explainable expert systems, but it's been a resurgence recently because of the AI boom, I think, and also just because of the machine learning models that are being deployed now. The sort of research from the 80s doesn't solve those questions. So it's coming back.
Why is it coming about now? What is so important about explainable AI today, and why is it such a hot topic today?
Firstly, it's because now we're deploying AI in lots of different application areas where decisions were made by people previously. And so we're telling people, you might have made this decision previously, but now we're going to delegate some of the hard work to something else, and we're going to tell you what the answer is. But then by definition, surely the answer is going to be different sometimes to what you would have come up with, because the AI can't take as much information, much sort of maybe different types of varied information in as you can, but also it can think a lot deeper than a human can. So if it's going to be different, the expert's probably going to say, don't believe it, that machine's broken, because that's not the answer I would have come up with. I'm the expert. So this massive deployment has led to this lack of trust from people who are doing it. But I think the main issue when you see explainable AI, it's really coming out not from sort of altruistic means of, I want to help people understand these decisions. It's just coming out from AI engineers can't understand the decisions their models are making, because these machine learning models, the modern machine learning models, especially deep learning, they're so complicated, even the people who build them can't understand them. So if you can't understand them, then you can't debug them, you can't improve them, refine them, these types of things. So I think people are saying, well, I want explanation for my own purpose as well. And so a lot of the research you see is really explanation for other machine learning engineers.
And where do the human intelligence experts, the psychologists, the people who, I mean, really in terms of the last frontiers, the brain is one of them. And I think as you get into defining what intelligence is, when you suddenly start thinking about it, it's quite difficult to verbalize what intelligence means. Yet we're, inferring those values and what each culture understands intelligence to be onto artificial intelligence. Do you get to hang out with psychologists? How are you getting to grips with that side of it?
Yeah, it's a difficult question. So you're right, we can't really define intelligence. It's just something we think we know it when we see it, and nobody really can come up with a clear definition of it. But yeah, I mean, you hang out, you go to AI conferences, and I work with some people who are psychologists and cognitive scientists, and there are people who are thinking about those really deep problems rather than, just I want to chuck some data to solve a problem. They're really thinking about how do we get more general AI that can solve multiple problems based on prior knowledge. And those people, but that's few and far between compared to people who are using AI as a tool now just to solve specific niche problems. So, I mean, and they're making some headway. Guys like Josh Tannenbaum and Gary Marcus in the States are making some increments forward, but still a long way.
And I guess from a society point of view, we've had decisions that have been made for us without explanation for a long time, whether it's your insurance premium or other types of credit scoring, for example. So decisions that are made without explanation, and we've been okay with that in the past. Why is that changing now?
Yeah, I think it's a good question. I mean, one is the proliferation again. There's more decisions being made from AI, but I think those are two really great examples: insurance, credit scoring, are things where we've had statistical models, but those statistical models have been built by actuaries, by hand, using their hand knowledge. So at the very least, they're making these models so that they can understand them, and then they're passing them on to people who can understand them because they're human devolved models. So if you are rejected for a credit score, you can ask somebody at the bank, why did I get rejected? And they can give you an explanation of what you had to do differently. But they can't give that explanation of a lot of the machine learning models, right? Some of the more modern machine learning models they're too complicated to understand for even the engineers sometimes, so let alone some poor person working in a bank who's just in charge of giving credit scores. Big challenge. So I think that's it. It's these things are human-made. They were human-made. Now they're machine-made, and they're not made for human readability and understandability. They're primed on accuracy. That's it.
Which is okay if there aren't tremendous consequences with it, I suppose. If it's some sort of weather forecasting AI, or we get wet tomorrow afternoon. But if it's driving cars or it's making medical interventions or otherwise, there suddenly is the human consequence of AI.
And on that topic, I mean, what's the flagship or the real the example of this is what can go wrong with a lack of explainability? What's the kind of the big example that springs to mind for you?
I can't think of any really big examples of things that have cost anyone their lives yet. Thankfully, it might have happened, but I think a pretty high-profile example now is Ibm Watson. They were pushing very hard to have this as a kind of diagnosis tool, figuring out what's wrong, recommending treatment plans, and they've had a really hard time convincing doctors to use it. I mean, they're scaling back investment in Watson as a medical tool now because when it doesn't work, it seems to. When it fails quite spectacularly. So there's an opportunity where I think having an explanation, if it failed, having an explanation of why it failed might have actually helped, right? As a moment, it's just a black box that says something ridiculous. But if it was something ridiculous, but it's because this one parameter here got it wrong, or that's like I know this kind of thing. Maybe that could have helped the doctors build some trust into it, but. That's the kind of a big high-profile case, and now you can see IBM working on explainable AI, and I think that's part of the reason is these types of investments are falling down. So,
and also, I guess that feedback loop. I think we were talking recently around Cathy O'Neill's book "Weapons of Mass Destruction," where she talks about a dynamic model where there's constant feedback with new data flowing in that can be validated, and the model can continually be iterated. And I suppose with examples like that, those models are quite closed loop, right?
Yeah, I think so. Yeah, I mean, I imagine they would be, or at least it's a very long time to get feedback on some of those models. So, I mean, I think it's very difficult then for them to do something about it. So, but even in that case, even if you can feed it back, maybe it's too late. Then the trust is broken. It takes very few. I think it takes very few instances of failure to destroy trust in something like that. No matter how many nice statistical tests you've got in your when you tested this in the lab, couple of bad failures for a doctor, that should be enough to destroy their trust, I think. So.
My observation of this whole field of research and development in AI is I've never seen one that is as open and transparent about its research results. Now, your paper is published on, is it ARXIV, AR14?
Archive, yep.
How do I say ARXIV?
Yeah, it's archive.
So what an incredible place in terms of information being shared. Is it a particularly transparent community? You've been a researcher in other fields as well. Do you think it's makes a big effort to put its stuff out there for peer review? Is it unique?
I don't know if it's actually unique. I mean, Archive certainly has physics and other areas that seem to be pushing it, but the AI community particularly has embraced this of submit a paper to a conference or a journal and stick it on Archive at the same time, and we're getting out there as quickly as possible. I don't know whether it's necessarily the sharing thing that people are after, but this claiming the stakes in the ground. We did this first, so we're putting it out there and getting it out there as quick as possible. Yep. But the fields in kind of machine learning and reinforcement learning are moving quite fast now. People realise if I don't put this out now, someone's going to put it out in 3 months. So sticking out, but it definitely has this byproduct that now anyone can get hold of. Just about any machine AI paper that comes out is going to be available publicly somewhere.
I think it's a great thing because too much of science in the past has been hidden. I mean, the number of scientific papers I've had to buy over time, and I'm $50. I'm going, oh, this is the internet. Do I have to pay $50 to get that, paper on whatever it is? Kai-Fu Lee in that book has this brilliant, probably apocryphal story when someone asks a Chinese AI researcher, well, how far behind America do you think you are in AI research? And his answer is 16 hours, which is, of course, the time difference exactly between China and the United States, and attributable to platforms like this and the sharing nature of this field.
Mm-hmm. And there was an interesting, a sort of side comment about this, that the biggest journal in AI is called Artificial Intelligence. And for a while it was an Elsevier journal, and it was behind a paywall, and the community stopped publishing in that until they made it freely available to developing countries. And the publisher backed away.
Wow. I'm looking for more evil in this community. Where's the dark net of AI research happening at the moment? You don't have to answer that.
Yeah, I'll keep my mouth closed.
Yeah.
And so there's obviously a bit of a global community emerging on this XAI kind of topic now. So where are the other kind of pockets of research happening, and how big is the community on this now? Yeah,
it's quite fragmented, and there's bits and pieces of workshops coming along. And to be honest, I've been to a couple of these workshops when they're at conferences, and I don't recognise some of the stuff really as explainable AI. So that means people are interpreting this differently than what I am in a lot of the cases. So there's pockets everywhere, and it seems to just be what differentiates my work from a few other people's from the rest of the community is some communities have their particular model that they like. I use these, I use random forests. So that's hard to understand. I'm going to figure out how to explain random forests. Whereas some of us are taking a much broader perspective and saying, well, actually, maybe we should sit back and think about what a good explanation should look like first. And then once we figure that out, maybe then we can start looking at what they should look like for a classification problem or a regression problem. And it doesn't matter what the underlying model is just yet, but let's try and figure out what the goal is before we start figuring out how to get explanations out of them.
So, James, I'm not sure what the level of listeners for this podcast are necessarily, but we may have lost a few people at that moment. And it might be worth just getting it, like someone so in depth in the field who's used to explaining this stuff daily. Mm-hmm. So what changed between the worlds of simple mathematical algorithms that an actuary would have written? And I worked in insurance. They have algorithms with the variables are relatively simple about family life expectancy, etc. Mm-hmm. And this today where it's inventing stuff itself and learning. Is that the neural network? Yeah. Was that the revolution? When did that happen, and how did it become so complicated so quickly?
Yeah, it's a great question. So there's been a really small revolution in theory and in machine learning. So the deep learning, which is the hype that's around now, the major algorithm in that backpropagation was published in 1986. So we're talking over 30 years ago, and that's still the dominant, in deep learning, that's still the dominant algorithm that's being used. Tweaks here and there, but what changed was two things. Is one, the computational power, so the ability to compute stuff on the cloud, away from you, and or buy big clusters. All of a sudden, this thing became feasible. While we can actually crunch 1 million images through one of these to train it, to say detect objects. The second thing that changed was just the internet being able to give this data out to people. So you're talking about reasonably large data sets that even 20 years ago would have been quite big to download and to store somewhere, but now you can download them in a matter of half an hour, and so you can spread it around, and lots of people can work on the same data set on the same problem. The algorithmic things, there was one big breakthrough in the 80s. Now people make small changes, but
right.
It's not huge.
So that's interesting. You get to scientific nirvana then, repeatability of an experiment, which gives you validity, and no wonder this is moving so fast.
And I was sat on the beach on the weekend, and I read a very interestingly titled paper that you wrote. So it was Explainable AI, Beware of the Inmates Running the Asylum. Very cool title. What's the story behind the title in the paper?
Yeah, so the title of the paper, the title is stolen from a book from Martin Cooper, and it's actually a book on human-computer interaction called The Inmates Are Running the Asylum. And Cooper makes this observation about why are so many software systems so terrible to use. And he says it's because the design of the interaction is left up to software engineers who have no training in this. So what they inherently do is they just design the system for themselves. So they're deeply technical people who design the system the way they want it used. And this leads to systems that nobody else can use. And so I made this observation, and this was a short position paper in the first Explainable AI conference, which was last year, that on the Explainable AI research I'd seen, I saw the same kind of problems. People were taking their favourite model and trying to get information out of it such that they could explain it, and then passing this off. Well, this is good. Now we can explain decisions to people. But I made the observation that actually that's not going to work for the person who gets turned down on their credit score. That's not useful for the person who gets sent back to prison because they're told, well, you've got a 90% chance of reoffending. That's not a useful explanation. So we have to make explanations for other people. So we're the inmates, me and my friends who are technical people, and the other people, and we're writing explanations for ourselves, and the people who it really matters to aren't getting their say. So the premise of that paper was we need to, for example, for starters, do human experiments with these explanations. If we want to say that's a good explanation, we better test it on people. And the second thing I said was we should be collaborating with social scientists, cognitive scientists, psychologists, philosophers, human interaction people in order to build these things properly. And that's what the title came from.
Trust is a massive issue in this, isn't it? So it takes a bit for people to build trust in something. And I think someone said, trust comes in like a tortoise and out like a racehorse. Yes. And so one or two cases going wrong, and those things communicated rapidly across this wonderful internet that we have can kind of ruin it. I read a case study fascinating about financial advice. So you'd think that's a perfectly rational thing to do. You should have a portfolio. You should put money in all sorts of places. So these are the numbers. 10% of people would trust the flip of a coin for the advice that they took, column A or column B. 9% would trust a horoscope for advice tailored to them. And 8% would trust artificial intelligence.
So more would trust a horoscope than artificial intelligence.
And it could be that they have a science fiction view of what AI might be, or maybe they're deeply suspicious of it.
Which is interesting because you think about the uptake of recommender services in retail or music streaming, and uptake's incredibly high and people are very comfortable with those. But clearly that hasn't made the jump yet into other industry verticals like financial advice.
Yeah, interesting. So
the context of the paper is effectively, I think you've touched a couple of points there. First of all, proliferation of these systems is getting much broader. The complexity of these systems is getting much higher with the emerging tech around kind of neural networks and deep learning. We think about explainability as explaining it to the user, but we're really talking about explainability being more focused on the designer at the moment, and therefore what we think is explainable for a designer isn't probably going to wash for an end user or a consumer of a product.
Yeah. So there's some of the explainable stuff that comes around. If you think about using deep learning to do computer vision tasks, it's a lot about trying to visualize which parts of the image your deep neural net is looking at. And for listeners, I'm doing air quotes here, sort of what we're looking at, which is great for debugging. But I think it's probably pretty hopeless for giving an explanation to someone as they're trying to figure out. They're trying to look at images that classify rare species of birds, and you're just highlighting the parts of the image that the algorithm was looking at. I don't think that's a good explanation, right? The explanation should be more around what's the properties of that bird that made it that type of bird. And this is where we're lacking research right now. This is where people are really not focusing on that end user.
So, and you touched on trust before, Nigel. So you feel this is kind of one big AI news story away from causing a big problem?
Yeah. So, I mean, a really great case study in this is self-driving cars right now. You've probably seen the issue that Tesla had with an accident probably about a year and a half ago, where a big truck came out and the Tesla car didn't see it and crashed into it. It was fatal, unfortunately. And one quite recently, the woman crossing the road, pushing a bike across and got hit by an Uber car. I mean, that's two fatalities. You would say that's two fatalities too many. But they probably clocked up quite a few miles driving around without incident. I'm not sure. I don't pay that much attention. But those two made the news, right? Not the 100 days before that they'd driven without incident. So people engage with stories, not statistics. So a couple of stories out that sort of drastically showing that, this is a problem, and that's going to destroy people's trust in certain decisions. So, I mean, you talk about financial advice. It takes a couple of people coming out saying, I trusted AI to give me financial advice and I'm bankrupt. And the other 98% that might have done fine won't make it into the news, I think. So it's a big trust issue.
And we're seeing like a proliferation of new AI-powered products on the market. So talking to someone the other day around, a company pitching a CV scanning tool to, help you filter through candidates more quickly. And it's just one of many kind of new AI products that are kind of hitting the market. And Australian businesses are being approached by them to buy these kind of products. If you're a buyer in a business or you're an exec making a decision on a product, how do you get a sense of if good explainable AI principles have been applied in this product or not?
That's a great question. But, because you talk about principles and there aren't really many good principles around what it means. And so I think it's really difficult. So it's a hard thing to think about, like, is this system explainable in some sense? And the only way to really get it is to test it out and have your staff come in and try it out and see if they trust it. That's a difficult thing because you might employ it. It might scan a lot of CVs out, but if your staff don't trust it, they're not going to use it. So I think it's a really big problem. And I don't know how I would deal with it if I was in the situation of being approached to buy one of them, whether I would just buy it off the back of a sales pitch. I think I would say, well, we have to use this for an extended period and see whether people are going to use it and whether they understand it and whether it's making the right decisions over and over. But I mean, ultimately, I think there aren't really any clear principles. But I think other problems that come in, not just explainability, are things around sort of fairness and accountability of these algorithms, not just transparency. So the acronym is FAT, F-A-T, which is fairness, accountability, transparency that people want in their systems. Fairness means a range of things, but free from bias. It doesn't, for example, disadvantage female applicants from males, which I don't know if you saw the news quite recently of Amazon doing the same kind of thing, they're using their own data to train CVs, and it turned out because the Amazon staff who had been reviewing CVs were quite sexist, that meant that any CV with woman in it was automatically ranked down. Who's accountable for these decisions when they go right and when they go wrong? And transparency is kind of the another word for explainability, I guess, here, and people assessing those. They're the three things I think you'd want to think about if you were a CEO in that case.
So Melbourne Uni's getting a bit of a reputation for poking the bear here, aren't they, with the biometric mirror? Mm-hmm. It's such a wonderful story, well told, of, this is who you are and here's what it judges. It's kind of hilarious and engaging. And once the story unfolds about how it's done this and the underlying data set, and it's chilling to understand the biases built into its judgments Have you encountered much reaction to that in terms of being part of the Melbourne Uni community?
Yeah, of course. I know Neil Zvouter, the author, very well, and we've spoken about it a lot. And I hate the biometric mirror because it said I was old and grumpy, at least a lot older than I am and grumpy, so I hate it. But no, I really thought it was a fantastic project. And the day that opened at Melbourne Uni, I took my research group down to all have a go at it, and not many of them liked what it told them either. But I think it's a fantastic sort of instance of these things, and yeah, the reaction's been really fantastic. And Neil's impression is he's seen a lot of people use it, and his impression is a younger audience go, fine, that's what it says about me, I'm happy with that. Older audiences go, what is it doing? How does it know that? What's happening with my data? Are you storing that data? They question it a lot more than some of the younger audience. I don't know whether that's just level of maturity or whether that's really the younger generation is quite happy to give data away and not question what's going on with algorithms, and the older people like me aren't. But it's been really fantastic. And in fact, Niels has had a few companies approach him to think seriously about using this. Oh, we can get photos and use it as part of our recruitment campaign to tell if people are weird. And he said, well, no, you've kind of missed the point. That was the point, is these aren't, what does it mean to be weird? People have labelled some images and we've trained it to detect weirdness, but that's not a really great idea. So yeah, it's been a really great project, I think, and it's certainly something we're going to try and build on in our lab and in Neil's lab as well.
I think the role of universities in that sense is tremendous as a chance to get out there. And I love Melbourne Uni's art, science mix up here. This is really the field we are in now. This is way more than brilliant statistics and mathematics. This does have an ethical dimension. And Australia seems to be stepping up to that. I worry a little that Australia hasn't sort of, as again in that book I've been reading, the author describes China's Sputnik moment. So Sputnik and, the Russian satellite over America ignited NASA and incredible advances in space technology. The equivalent was AlphaGo beating the Chinese Go champion, and this ignited academia, business, venture capital, and the Chinese government to just go, that's never happening again. We will win the AI race. Has there been a Sputnik moment for Australia yet in terms of our part in the global AI field? Maybe it's your space that is something we could be particularly good at. Yeah,
it would be nice. Certainly, as far as the maths and data type AI, I mean, we just can't compete with the States or China. They're huge. They've got so much money sloshing around to do this kind of stuff. Really great institutions. A lot of Chinese institutions are just shooting up in sort of rankings and quality, sending young people into the States and to the UK and to Australia to do PhDs and then coming back and setting up labs. Lots of funding. Can't compete on that space. I think what we can compete on is things such as what Canada's trying to do and Sweden's, and what kind of drew is around the responsible AI thing, which is, okay, we can do this, but is there a niche here to say, is this being deployed responsibly? Is this, sort of the fad? Is it fair? Is it accountable? Is it transparent? Is this what we want in society? How do we actually make all those type of judgments? James's question, what is the principles around these things? Oh, we don't know those types of things, but I don't see China trying to tick them off anytime soon. So let's try and get one of those niches and focus on something, even if it's something Australia-centric. That's where I'd like to see it, but we'll see.
And I think one of the things that surprised me has been, the more that I've read, and I just finished Automating Inequality, which is a fascinating read. And what I was surprised around was the proliferation of automated decisioning systems in the public service, and that we think AI and we think Netflix and Spotify and Amazon, and there's this whole other set of AI products and services out there being deployed in high risk areas like justice and welfare. And Automating Inequality, fascinating read. I highly recommend the book. And what I learned from those is that very rarely is a machine making a decision with no human involvement. It's automating part of the chain, not the entire chain. And if there's a human in there somewhere, this point around explanation becomes absolutely critical. Otherwise, it's either wasting effort or it's sending them down the wrong path. I think people are surprised with just how quickly some of this technology is coming along in the public service. Do you see this happening in Australia? I know we had the robo-debt kind of scandal, but are you concerned that Australian government will embrace this tech the same as perhaps the US has?
So I'm not so concerned about it. Well, I'm not sure whether I'm concerned about it or not. What I mean by that is, with a lot of these systems, probably around about 12 months ago, I talked to a handful of legal experts, lawyers, people in our law school, people in legal aid about what do you know about these systems coming? And I got either an answer that was, it's not going to happen here, that the Victorian government's too risk averse and the Australian government's too risk averse and the Australian Legal Association's too risk averse, or just, look, I've never heard of these things. So either people know stuff and they're not telling everyone about it, or they're not really coming that quickly. But there is a good counterexample, a bad counterexample to this, which is the STMP system that's operating in New South Wales.
It's domestic violence predictor, right?
It's just crime predictor in general. I can't remember what it stands for now, but it's targeted stuff, and this is effectively predictive policing. This is going and saying, we think this person's going to commit a crime based on their previous history and some piece of data. And according to the report on this, people's houses are being raided in the middle of the night because of a suspicion they might be committing a crime in the future. I don't know, the technology behind it hasn't been disclosed. I don't know what's being built around. But it's a particularly bad case because if you talk about bias in these decisions, it's a really biased system. So, I don't know what population New South Wales is Aboriginal, but more than half of the people targeted are Aboriginal or Torres Strait Islander on that system. I don't think the Aboriginal population is more than 6 or 8% in New South Wales. So that's a ridiculously strong bias against one group. The police commissioner says, that's a shame. That's really unfortunate. I'm embarrassed about it. But this is an important efficiency tool, so we're going to keep applying it.
And the whole predictive policing thing, just when you take a step back and you realise that when a police officer is sent to a particular area, what are they doing when there's not a major crime happening? Yes. They're booking people for minor crimes, which then once you're booked and you've got a record, and then you introduce things like models that assess your risk of reoffending, you're suddenly going to be triggered again and again. Yeah. And that you're just automating this creation of bias all the way through the chain, which is quite frightening.
Yeah, exactly. These systems are sort of self-reinforcing. You send people out to those communities, they get booked more, they get pulled in, and I think this is a big problem. And I guess part of it is there's one argument that people make that says, well, humans are biased. Humans are biased, so that's fine. So these algorithms are biased. It's human data. At least now we're consistent and we have a chance to remove our bias, which is a lot harder in people. But I think things like predictive policing, I think just the general idea of predictive policing should be questioned, not what algorithm or what data we use. These kind of things all of a sudden enable this idea that we could do predictive policing, whereas before I don't think we were really thinking about that. And I'm sure that kind of effort can be put in more into maybe not predictive policing, but identifying people who've already been arrested or already been in prison and say, okay, maybe we should try and predict what type of program is going to work for them to stop them reoffending when they get out, rather than just releasing them and then picking on them later. Maybe we should put the effort into something more around not predicting whether they'll do a crime, predicting which program is going to work best for them to rehabilitate them and these kind of things. But I don't think we're going to see that.
Probably a healthy level of cynicism on that front. So going to put you blokes under the spotlight here. So Australia's National Health Record System that's been proposed recent, opted in or opted out?
Opted out.
And okay, that's a fascinating answer from a scientist. Why did you opt out of that system?
I think it's really unclear what's going to happen with the data in those systems.
So transparency issue.
Mm-hmm. There's a really clear transparency issue. So from that kind of reason, from a pragmatic reason, I have several colleagues who are experts in differential privacy, and they all opted out. And the only one who didn't opted all of her family out, but she said, well, I actually want to see what data of mine goes on there, so I'm going to stay in. The rest opted out and opted their family out. So the experts on the field tell me, get out. I think, okay, I'll just appeal to authority and get out.
So it's fascinating to me that Australian citizens are being asked to make some pretty tough decisions right now and judge trust of future governments as to how that data can be used. James, in or out?
I stayed in for a similar reason to your colleague. I kind of want to see what happens. I think if anything, the question in my mind was that, and less around the transparency, but more around the purpose of the system. And hearing from doctors talking about it's a generalized kind of set of data. It's not actually what I need to do my job. So that's the bit that I think put me off the most. But yeah, I thought I'd stay in and see where it takes me.
The thing that scared me the most, and I've stayed in out of an experimental mindset, I've had my health crisis in life, did that years ago, and is just the inability of the bureaucrats and the politicians to actually explain what it is. I mean, this is not even algorithmic in its nature, but to explain the meaning of the system in anything other than the most simplistic PR expert-driven one-liners is pretty disturbing. And it was good to have people like you around who enforce the kind of ethic of explainability, that's for sure. But we're not getting it, not at the moment.
No.
And on that kind of topic around government, I mean, we've been watching kind of GDPR emerge in Europe as a pretty, the bleeding edge, I guess, of good governance and regulation around data. And I think there are a few conditions in GDPR around automated decisioning. Is there anything that you're aware of specific in GDPR around explainability?
Yeah, so that was interpreted when it first came out as a right to explanation, and there's certainly clauses in there that are around if a decision is made around an individual that could impact them, they have a right to know. I don't remember the wording, but they have a right to know why that decision was made. But subsequently, that's been watered down a little bit, and of course, it's debatable what that means, like what an explanation means. So I could interpret an explanation as being, we made an explanation and these were the factors we used. This was your data that we used, these 8 things. Is that an explanation? Well, I guess that's part of one, but because there's not really any clear idea of what explanation means, I think that is an explanation. But that was definitely interpreted as a right to explanation for individuals, and that's driven. Maybe it's in the paper you read. I can't remember. That's certainly driven people in Europe a little bit to take the explainable AI field a little bit more seriously.
And then kind of closer to home, Dr. Alan Finkel created a few waves with the Turing certificate idea that he put forward, which is effectively like a standards measurement or standards metric for AI. Is that something you think's a step in the right direction? And do you think explainable AI would be a component of the Turing certificate?
Yeah, I think that's not a bad way of doing things. I mean, he was kind of proposing it as a way of sort of anti-regulation, sort of self-regulation from an industry point of view. Well, at least it's complementary to government regulation. I think it's a really great idea. And will explainability play a role? I mean, I think the FAT will play a role: fairness, accountability, transparency. And if we consider explainability as one way to get transparency, yeah, I think that would play a role. And I think that'll be one of the important factors in that Turing certificate, I imagine.
I wonder if there's a future where we have to build AIs to interrogate AIs, and because the complexity of their algorithmic outcomes, with recursive years of data going in and years of prediction, only an AI will be intelligent enough to actually reverse engineer what on earth happened in those situations.
Yeah, I mean,
business idea right there.
Yeah, that's right. I mean, it's not that far from what I think it's at Berkeley. They're doing something similar. I mean, their approach is the solution to explainable AI is just more AI. I don't agree with that, but certainly it is part of it. Is in their training algorithms to recognise what were important parts of the decision to fish out, and it's kind of similar to that, right? Because they can't interpret it themselves.
Jeepers, the auditors of the future are going to have a tough time, aren't they?
It's funny you say that. I was just thinking to myself that you gave the example before of an actuary, and an actuary could explain something to a human being like an auditor, an internal or an external auditor, and say, well, here's how my model works. If you're an auditor now or preparing for a career in audit, I mean, do you think explainable AI will be just like another thing that the big 4 firms offer, like an audit service?
Yeah, maybe. I mean, that's another business idea. I think, yeah, that's a good point, right?
James, if there's money to be made in it, I think the big 4 will be all over it, mate. So,
Tim, you've got some travel planned soon, as I recall. Where are you off to? What are you talking at?
Yeah, so I'm going to Florida for what's the ICRTTS or ICRRTS? I forget, robotics conference there. But I'm invited speaker at the Explainable AI workshop, which is part of the conference that's going on there. I think it's something like the 5th or 6th of November, or I forget what date it is. But while I'm there, the main purpose of the visit really is I'm going to the Institute of Human Machine Cognition to visit a couple of pretty high-profile cognitive scientists who kindly paid my way to get out there and sponsored my conference, Rego, who are the lead of one of the DARPA Explainable AI projects, the sort of more cognitive side of things. And I'm going to spend a few days with them.
Yeah, I saw you reference to DARPA. Can you just explain a bit more about the background, who DARPA are and the work they're doing?
Yeah, I mean, I think that they fund mainly defence research. They're a basic research organisation who does funding but also project organisation for large-scale projects. And they funded a program called XAI. I think just over 2 years ago it started. They had 6 large projects and funded different institutes around the North America to look into explainable AI. And they do similar things around the place now. Their current call is around sort of third generation AI systems, which we've had the sort of symbolic expert systems revolution in the 80s and 90s, now the data-driven machine learning, the sort of noughties and recent decades. And now they're looking at sort of context-aware artificial intelligence systems, and they're funding, looking for large projects in that space.
When you say context aware, how do you mean?
Well, okay, that's a pretty difficult thing, but so effectively algorithms that are aware of the context in which they're making a decision. So it's a very subtle thing to talk about here, and I'm not sure that anyone understands what that's going to mean. But really, what they're looking at is things like machine learning algorithms being partnered with the older symbolic techniques in order to get more of an idea of how to make decisions that don't just mean one-shot predictions. They mean systems that are operating in an environment over a long time, in order to sort of improve things such as autonomous driving. So if you think of the example of the Tesla car, the Tesla car that had saw a truck coming across the road, then the sunlight hit the camera, and so the truck effectively disappeared. And it kept going because it didn't have any context to the fact that trucks move and they don't disappear. And so when it disappeared, I should assume that it keeps driving in that direction. It didn't have any context. It was just operating off reams of vision coming from a video, and there was nothing in the video, so I'll keep driving. So these types of really hard problems that machine learning and symbolic AI don't solve on their own.
Sounds a lot like the progression from narrow to slightly more general, or one small step on the general kind of spectrum.
It is exactly that, one small step towards general AI, I guess. Yeah.
On general AI, I'm hanging out for my Google Pixel 3 phone with the duplex-driven Google Assistant on it. Have you seen the video of the lady who organises dinner for her husband on the night off?
The hairdressing appointment as well. It's pretty cool, isn't it?
How is this? Do you know much about Google's program? I can't work out how much of that's just lines of code and they've figured out every possible question you could ask a restaurant, and it's scripted interactive voice response versus the actual learning component of it. Mm-hmm. Any insights for us from the expert side?
I have some idea of how it works. So it's a bit of both. There's a lot of learning that goes in there. But it's still pattern matching in the machine learning sense. So the reason that you can book hair appointments in restaurants and not get them to ring up and change a cable service, at least yet, is because they had to build that for the specific context of restaurants, right, around those things. But it's still quite pattern based. And so I thought that was quite an impressive demo. The real sounding voice was very impressive, and the way that it responded to questions, it was quite impressive. But I don't think it was quite as impressive as what the demonstration made out, which is not surprising. I wouldn't demo my bad examples either. But if you think about that example, there was a question where the duplex rang up the restaurant and said, "I want to book a table for 7 p.m. And the woman said, "You want to book a table for 7 people?" And she said, "No, I want to book it for 4 people." And I think it was just responding. I don't think it had figured out that this woman had made a mistake and it was backtracking its question, because that's not how I would answer the question. If I said, "I want to book a table for 7, and James said, "You mean for 4 people?" I would have said, No, I said 7 p.m. I want it for 4 people. But it just went, I want it for 4 people, because it heard the question come in. Oh, this question's about people. What do I need? I need to answer a question about people. I've got that data. I'll push it back over. And so a couple of things where it recovered from, I think it just got lucky. So it definitely recovers, but I don't know that it's quite as intelligent as what the people anthropomorphize.
I think there's quite a bit of human life where we actually just get lucky.
Yeah.
I think 99% of conversations in bars and pubs, we get lucky.
Yeah, exactly. But Yeah, but it worked, right? It did recover. So it's impressive that it was able to just jump to another part in the dialogue and keep going.
So you've seen this one with El Cockatero, the woman who's got the assistant on her phone, and this is the next round. So they've tried to make it a lot less frightening of her walking down the street and a chance to book this restaurant. And so there's some interesting changes to it. Number one, the voice of the Google Assistant is male, where I'm seeing a lot of heat on the Twitter world about this personalization of the digital slaves as women as being pretty offensive. So that was an interesting change for them. And of course, this call can be recorded. I'm a digital assistant called out right at the beginning of the phone call with the restaurant.
Yeah, because that was one of the other big backlashes that came off the duplex demo, wasn't it? There's no disclosure that you're talking to a machine.
That's right. But I mean, I think for the purpose of what they were trying to demonstrate, which is the fact that the person on the other end didn't know, I guess they had to do that. But I imagine this was, you have to reveal that. And I think you're kind of crazy if you don't, if you're a company. And I think pretty soon governments will regulate, look, you have to, if you're not going to do that, we're going to force you to do that because it's important that people know. But I think you're kind of crazy too, because they will fail and they'll have to push back onto the person they're making the call for, and that's going to confuse operators if they don't know. So
yeah, we're in this crazy mixed time between them being just purely scripted conversational IVR-like systems and the damn thing's learning so quickly from the diversity of humans they're going to get to talk to. And I think that's the scale of the mobile world that fascinates me. If everyone gets a Pixel phone with duplex in it, and Apple will doubtless follow with Siri's upgrade to being a more intelligent learning tool. We could be at the kind of that exponential acceleration moment, or do scientists believe in those exponential acceleration explosion moments?
Yeah, there's groups of people. I don't know if you've read Super Intelligent by Nick Bostrom. He's a philosopher from Oxford, and I mean, he talks about the acceleration moment, especially when someone invents an artificial agent that's more intelligent than humans, then it can start improving itself. And I think some people kind of think we're there. I seem to think we're probably plateauing a little bit. I think we've made the big jump that machine learning is going to give us. We've got some benefits there. We'll keep going in that way, and we'll keep flatlining along as these systems will keep happening. But I think as far as research goes, we're going to have to come up with something new real soon, and it's not coming. It's not just piling more and more data into these systems. They'll get incrementally better, but I think we've kind of reached a bit of a peak maybe, and you can see it. I was at ICML, which is the International Conference of Machine Learning, in probably July, and you can see some of the experts saying, "Oh, well, these are the limitations we found now," and people are starting to pick out the limitations of these systems and what they can do. And
it sounds like an AI autumn, not quite an AI winter, but an AI autumn on the horizon. There.
Yeah, it is a bit of an AI autumn. I think there's a big risk of an AI winter coming, at least from people like researchers. People won't want to fund it, but I mean, it's not. These systems aren't going anywhere. We've demonstrated the value of having data and maths and doing stuff. They're not going anywhere, but I think that the hype curve is flatlined. I think
So I've learned something tremendous today, James. You know, I'm a trivia hound and a historian. 1986.
Backpropagation.
Have you got a minute to tell us about that time in history? What was going on? Where were those people? What were mathematicians? Or
no computer scientists. So Geoffrey Hinton was the main person in the paper. He was at Toronto University. And in fact, I mean, if you want a history lesson, neural networks, which is what that's based on, was actually first proposed, I think, in 1943 by McCulloch and Pitts. And I think one of them was a logician and one of them a cognitive scientist. And this is what we think the representation in the brain might look like, these neural networks. And they showed, oh, look, if you structure these simple things, you can learn, simple sort of Boolean functions, they were called, and they published it. And it was kind of interesting. And this, when you think about this, it was 43, I think. The computation wasn't around, right? The only computers in the world were at Bletchley Park and these types of things in the World War. These guys probably didn't know about computers and what this could happen. So people started building on that idea, guys like Minsky in the 70s, started building on this neural net idea and showing, you can learn general things by structuring these. And then they learned that if you sort of put some of them on top of each other, you can learn different things. But they were sort of not doing that well, and it was Hinton and his crew who came up with backpropagation. Sort of worked all right, and then they entered a image recognition competition. I think it was 2012 or 2013, and just blew everyone out of the water. And that started the hype on deep learning.
That was when Hinton was at Google, right?
I'm not sure where he was. I think he was still at Toronto. I'm not sure, but
because he's at Google now, isn't he? I believe?
Yeah, I think so. But I think he's also coming back to the Canadian government of funding a big AI centre in Toronto. I think he's coming back to lead some labs there, to lead a lab there. But yeah, I mean, that's effective. It's been around since 43. So, but the sort of main back propagation algorithm that led to this is the theoretical jump that was made was in 86.
I love that. And so this is academics' fault, and now academics are going to fix it for us.
Exactly.
All right, so you got a trip to the US planned. You're on the tour over there. You got anything coming up in Australia for our audience who might want to engage with you locally?
Yeah, so the one that you know of, the Churchill meeting, because you'll be at that. So I'm on a panel at the Churchill Club. What's the date? I did write down the 14th of November with James and a couple of other people. Where we're talking a bit about ethics and AI. And then I guess the interesting event will be on the 22nd of November. We've got Professor Virginia Dignam, who's the chair of ethical and social AI at Umeå University. So Sweden is one of these, they're backing themselves in AI and around responsible AI a lot. She'll be out here. She comes out and visits pretty much every year, and I'll be doing a sort of responsible AI Melbourne meetup again, which James knows a bit about these meetings on the 22nd of November at University of Melbourne from 6 p.m. I think. So if you search on Twitter, you'll be able to register yourself for that. And I'll be doing a Q&A with her about her career and what she thinks about responsible AI. So you can come and participate and tweet your questions in, and we'll...
It's like a Rolling Stones tour you've got planned.
Yeah, it is a bit. You should see Virginia's. She's just come off the back of about 8 talks in Europe, and she's got a few lined up in
China
Melbourne.
on your agenda at some stage?
Not anytime soon, no. Few Chinese PhD students, so I'm getting the context from them. So they're all very interested in this topic right now. So
yeah, I can imagine.
Magnificent.
Well, Tim, it's been a pleasure having you on the show. Thanks for taking the time to come and talk to us.
Thanks very much for inviting me.
Hopefully we'll talk to you again soon. Thanks, Tim.
Good night.
Thanks for joining us on AI Australia. We hope you got a lot out of it. If you enjoyed the show, feel free to leave us a review on iTunes by searching for AI Australia and giving us your honest feedback. It goes a long way to boost our visibility when you do that, so we really appreciate it. As always, we'd love to hear from you. To get in touch, head to eliiza.com.au/contact and drop us a note. Thanks again, and look forward to seeing you next week.